Hi everyone. In this video we are going to talk about something very simple but very important, that is the divisibility of the integer. You might have heard that people say 3 divides 9 or 5 divides 20. But what does that really mean? Let's find out. So when we say that an integer a divides the another integer b, where we are taking a is equal to 0, it means there is no remainder when b is divided by a. In easy words, if one number can go into the another number exactly without anything left over, we say that it divides that number. For example, here we say that 5 divides 20, because when we write 20 by 5, we are getting a 4 with nothing left behind. Or when we say that 2 divides 8, it means 8 is divided by 2 and we have 4. And when we say that 3 divides 9, it means 9 is divided by 3 and we have 3. And when we say that 4 divides 20, it means 20 is divided by 4, that is equal to 5. So see, if there is a no remainder, we say it divides. But if there is a remainder, then we say that it does not divide. So in this case, we can say that A divides B when there is a no remainder after it, or we can say that B divided by A, that is equal to integer. This can be written as B by A. We read it as B by A, and that is equal to integer. Let's suppose that is equal to some integer C. Or we can say that A divides B if there exists an integer C such that B is equal to A times of C. In this case, when we say A divides B, means B by A, that is equal to some integer, suppose C. It means we write B by A is equal to C, or B is equal to A times of C. So it means A is the factor or divisor of B, whereas we call B is a multiple of A, because we write B is some integer into A. So we can say that B is the multiple of A. And when we say A divides B, so we use the notation this. And when we say that A does not divide B, we use this notation. So in the previous case, we learned 3 divides 9. So we represent it as this. And when we say that 5 divides 20, it means we represent it as the 5 divides 20. So there is a two notation. One, we say that A divides B. Another is B by A. That is, B is divided by A. So two different notation we have and the meaning is same. So we read it as A divides B, and here B is divided by A. And in the second case, when we say that 3 does not divide 10, this statement is represented as 3, we write divide and then we cross it and then we write 10 here. So 3 does not divide 10. Now we will learn some very useful rules about the divisibility. So first theorem we have, let A, B, C are the integers where A is equal to 0. Then we have these three results. Let's quickly explain these one by one. First, if A divides B and A divides C, then A also divides their sum, that is B plus C. For example, 3 divides 12 and 3 divides 15. Now check whether 3 divides 12 plus 15. Yes, because this is equal to 27 and 3 divides 27. On the other hand, if A divides B, then A also divides B times of any number C, where number is integer. For example, 4 divides 20, that is equal to 5. Now, if we multiply this by 5, so whether this is applicable? Yes, because 4 divides 100. Third, if A divides B and B divides C, then A also divides C. So if 2 divides 6 and 6 divides 18, is 2 divides 18? Yes. Now let's prove this one. So let's prove the first statement. If A divides B, this implies B by A is equal to some integer. Let's suppose it is a K1, where K1 is any integer. Now, if A divides C, it means C by A is again some integer. So there is no remainder behind that. So we can write where K2 is any integer. Now we can add these to 1. Adding 1 and 2, we have B by A plus C by A, that is equal to K1 plus K2. On left side we have B plus C by A, whereas K1 is integer, K2 is an integer, sum of the integer is a new integer, let's suppose K. From here, we can conclude that B plus C is exactly divisible by A, or we can say that A divides B plus C because that is equal to the integer by the definition. So it's a very easy to prove the statement. Similarly, we can prove the next statement. For the second case, if A divides B, we need to show that A divides B into C for all the integers C. It's very simple to prove that. We will take the condition A divides B. So if A divides B, it means B by A is equal to some integer, let's suppose K1. Now we need to show B into C, so multiply both sides by C. So we have B into C by A is equal to K1 into C, where C is any integer. So K1 into C is another integer because the product of two integers is integer, let's suppose K. So we have B into C by A is equal to some integer. So by the definition, we can conclude that A divides B into C. So this is how we can prove the second statement. Let's prove the third statement, where we take the condition if A divides B. So we can say that B by A is equal to some integer K1. From here we can write B is equal to A times of K1. Let's suppose this is equation number 1. Now take the second condition. If B divides C, it means C by B is equal to K2, where K2 is an integer. So from here we can write C is equal to B times of K2. Let's suppose this is equation number 2. From 1 and 2, what we can do, we can plug the value of B here. So this gives you C is equal to A times of K1 into K2, where K1, K2 are the integer. So product of two integers is again an integer. We can write A into K, where K is equal to K1 into K2, and that is an integer. This implies C by A, that is equal to K. So as per the definition, A divides C. So this completes the proof of the third statement. Now here we have very important result that is called as a linear combination. If A divides B and A divides C, where A, B, C are the integer and we take A is not is equal to 0, then A must divides the linear combination of B and C, where linear combination is represented as B into some integer plus C into some integer. For example, when we say 5 divides 20 and 5 divides 35. So whether 5 divides 2 times of 20 plus 3 times of 35? Yes. How? Because this is equal to 5 divides 145 and that is applicable. Now why this is true? Well, A divides B, it means B is equal to A times of some integer K, whereas if A divides C, it means C is equal to A times of some integer, suppose F. So X times of B plus Y times of C, it becomes X times of A into K plus Y times of A into L. So we can take A outside and we have X times of K plus Y times of L. As X, K, Y, L are the integers, so we can write it as A times of some integer, suppose M, where M is equal to X times of K plus Y times of L and is an integer. This implies X times of B plus Y times of C by A is equal to some integer M. Or we can say that A divides X times of B plus Y times of C.